This is 2.c sinusoids. Here's we begin with revision of continuous time signal, a continuous time sinusoid signal y of t. And y of t is defined for all real time, and it is in this example a cosine with amplitude a and a frequency f. So frequency cycles per second, and we are multiplying with time, so it's how many cycles. And when we multiply by 2 pi, we convert cycles per second into something called the angular frequency. So this is radians per second. So when we do radian per second of omega times time, which is in second, we end up with only radians. And radians plus another phase shift, which is still radian, then the entry into this cosine is a radian value. So cosine radian value. So it makes sense. Now let's interpret what does f means here. F means if you start from time 0 and time 1, f will tell you how many cycles, a cycle of a sinusoid that will make in 1 second. In this example, you see that actually we made one complete cycle. So f is equals to 1 here. And if you divide by f, 1 over f, you will see that this is the time taken to complete one cycle. So this is called a period. A here is this value, the amplitude, how high it is when it reaches the top. And phi here is the phase shift. It is a radian value, and here minus pi by 3. Basically, you realize that we have shifted the peak of the cosine to the right hand side by pi by 3. Then you say, where is pi by 3? Because we are actually shifting time. So you need to learn how to convert phase in radian to time unit later on. In this particular example, you will see that in 1 second, we are shifting by one cycle. One cycle is 2 pi. So when we shift by pi by 3, you are actually shifting by 1/6 of a second. So if you here, you can check that it is 1/6 of a second. And 1/6 of a second in this omega equals to 2 pi by 1. 1/6 of a second is equivalent to 2 pi divided by 6 is equals to pi over 3 radian. So this is the question that you have to answer. What does t equals to 0 means? Basically it means that we are observing this value of a cosine omega times 0 plus phi. So what will this will result in is a cosine phi. And therefore this value here exactly is this value over here. So these are what you are expected to know from your A levels as well as your poly. So we are going to continue now to what happened when we increase f. F as in frequency. Here in the top figure, we have f equals to 1 Hertz. It means that in 1 second, when we repeat, when the cosine repeats, it takes 1 second. F is 1 cycle per second. So we could take 1 second to complete 1 cycle. That's the idea. What about here? We now have 1 cosine 2 pi 3t minus a phase shift. Here, f equals to 3. So f equals to 3 means in 1 second, we would go through 3 complete cycle of this cosine. So let's check 1 for the first cycle. Now we use a different color. The second cycle, And now we use the third color, the third cycle. And then we see that really it took only 1 second to complete 3 cycles. Alright, what about this phase shift? So to understand this, all we need to do is to substitute t equals to 0 here. At time equals to 0, this guy is removed, so it is 1 cosine minus 1.05. And you will realize that this value is y, or time equals to 0. And when time equals to 0, it is here at the bottom. And then this value here is exactly 1 cosine minus 1.05. Okay, so this is what we are trying to explain for continuous time. Now, in the next slide, we'll go through how to convert a continuous time signal into a discrete time signal through sampling. Thank you.